Okay, so here's a fun little assignment using a zoo animals data set. So first what you're going to do is you're going to load the data set that you found that I gave you. So go and open that zoo.csv that you downloaded. And now that it's active here in this window, what we're going to do is we're going to perform some clustering analyses on this. So the first we're going to do is notice that there's animal name, so we want to kind of remove that label when we get to that point. And then we also have the features here. And so we're going to take those 16 features into account, as well as a class type. And you notice there's 7 class types, so we might consider that as our number of clusters. What we'll do an analysis using clustering and hierarchical clustering to give us a dendrogram here. So we're going to put the 16 features into there, like so. So we're going to select these 16 features and move them over to the Y column. And we're using the words method with Euclidean distance to generate this dendrogram here. And so we have some choices on groupings. So we could see that with these long vertical lines, there's perhaps 4 possibilities, but then the class type has 7 possibilities. So let's start with 4 and then go from there. So we'll put that into our k-means clustering, and we're going to select again our features. So you could either do one at a time and drag them over to the Y column like so, or a faster way is if you click the top, hold down your shift key, and then click the last feature and then click on Y columns, and that moves them over as well. So we're going to do this, click OK for the k-means, and we'll do, we said 4, so we'll see how that goes. And we go, and we have our k-means clusters. And you could do more, so you could try 7 and see how that goes. But this is what 4 looks like. And so we were like, okay, well, the first cluster, we've got the and we can click on cluster standard deviations as well, so you can see the that metric. But back to the means, if you notice, like cluster 1, the majority, 100% have hair. Nobody has feathers. Very few have eggs. All of them have milk. Very few airborne. So about 10% aquatic. Predators. So this is kind of all mixed together. So you know what, this may not be the best number of groups. So let's try the other idea. Let's try using 7. So let's do that clustering, k-means, and let's pick all the features again, hair, down to domestic or down to cut size, into the Y columns, and click OK. And then let's try 7. So 7, go, okay, let's see what that looks like. Oh, that's a 4 one. Let's get that out of the way. For 7, we have, the first one is row 1, cluster 1. We've got 100% data points in there. 100% of the animals have hair, no feathers, no eggs, but 100% have milk. Very few airborne, about half are predators. They have teeth, backbones, they breathe air. Nobody's poisonous, nobody has fins. This is just the average of the legs. That's not binary. The others are binary, but the legs is not. And then 85% have tails, 22% domesticated, and then 75% are cat size. So that's clearly mammals. And so these might be more clear as far as interpreting the groups to do 7. And I did that based on class type. A dendrogram helps too, maybe if we grouped it a little differently. But this was actually from the class type. And let's see what else. How about 4? 4, cluster 4, 95% have feathers, eggs, 100%, 76% are airborne, about a third are aquatic, half are predators. Yeah, 100% background, breathe air, and they have tails. So this one's probably also pretty clear as far as birds. So that's how you can interpret these clusters. Okay, so let's go ahead and do a graphical visualization now. If you go to graph and then scatter plot matrix, and we can do like a bivariate comparison here. There's a lot of features, so it's a little bit challenging, but let's try. May not be able to do the bivariate, but let's try this. And okay. So it does attempt to do that. It's a little bit messy, so let's do a graph builder.